Hi everyone. Thanks for coming to my talk. My name is Joannah, and today I'm going to be talking about Python in general. So don't be misguided by my title. We will never have Python 4.x at any one point in time. So from Python 3.9, we went to 3.10 to just avoid the bias that came between the transition from Python 2 and 3. However, my talk is going to revolve around the question, what do we all expect in Python? And throughout my talk, you'll find that this question is going to really lie on each of us as an individual. So before I continue, let me tell you something a little bit about myself. I'm a full stack Ugandan. I am originally from Uganda, somewhere in East Africa. And but by background, I'm a software engineer and an aeronautical engineer, though I mostly practice software engineering and do aeronautical work for a passion. So it's something I do over the weekend or something. As a software engineer, I've worked with a couple of companies, mostly in fintech, developing banking software that runs on top of core banking. I've had the privilege of working with companies like Laboremus and fintech in Uganda. So I am a very avid open source contributor, and I started to contribute to open source through summer programs like Rails Girls Summer of Code. I'm sure some of you have heard about some of these summer programs and Outreachy. So, and over time, I've learned a lot of stuff, become an author of a Python book. You can check it out. It's all over the place on Amazon and other major book sites per se. After some time, I moved over and went into research, and I'm currently doing research on garbage collection in Python with IBM and the University of New Brunswick. But I'm also, as part of my research, I'm enrolled as a PhD student. I'm also a Python core developer. That means me, Guido, and other core developers have the privilege of maintaining the Python programming language. I am also a huge fan of PyLadies, and as part of my time, I organized PyLadies Kampala. So let's get started. So most of us have come here. We've come to PyCon because we love Python. Yeah, it could be for so many reasons, but at least we are united by the fact that we love Python in some sort of way, either because we use it or we are learning it or something. So I started to program by going for a Gauss event. It was called Rails Gauss during that time. And in Rails Gauss, really, I went there to have snacks, to eat some snacks. I didn't really want to program, but I kept going because the events usually were like on a Friday, and I didn't have programs to do. So I just went there to have a few snacks. But over time, I started to get curious about programming, and through the Rails community, to my surprise, I started to work on Python projects through the Rails community. So through Rails Girls Summer of Code, I worked on Qt Browser. That was a Python project. And that's why I use Python up to now. So I celebrate it and I love it because of that a lot of changes. It has had a great impact in my life. So regardless of why you came to love Python, it's irrelevant. For me, it was snacks. You may have a different story, but at the end of the day, we are gathered here because we love Python and because it's been a popular and a successful language. Successful because we've been able to have very successful use cases for it, running Python on the web, running Python for microcontrollers, running Python in different aspects of life. Now, before I talk about the successes of Python and what came, let's just look at what makes us a successful language like Python. So research has shown, a couple of papers have been written about with a couple of surveying different developers and interviewing them about what makes you adopt a language, because developer adoption leads to success of a language. And surprisingly, adoption of a language has not really been traced back to very cool features. By cool features, I mean very sophisticated things like reliability, performance, simple semantics. And now I'm not saying these features are really useless, but surprise, this is not the biggest thing that makes people come to languages. You may have a different story. Instead, a couple of research has come to the conclusion that successful languages are highly a result of accessible libraries, meaning are the libraries open source? Are they easily accessible to developers and anyone that wants to use them? But also the proof of usage in terms of existing code. I think most of you know the most important skill of a programmer is to copy and paste. So I mean, copy and paste some code and live in peace thereafter. So these factors have affected most of our adoption, at least for me and many other people, but also the aspect of experience, so how long a language has been in existence and how many people are using it, how many applications are using a particular language. These are some of the factors that have, through research, that have affected the successfulness of different languages, Python inclusive. So in summary, from all these findings in academia and different people, we can come to the conclusion that a language is mainly libraries, its libraries, and community. Now let me break this down more for Python. So if we're talking about libraries, we're talking about the standard library in Python itself, the language, but also what we call PyPI, which is the home for Python packages, what we usually call the Python cheese shop, really. That's where we get all our batteries, but also the language itself has some batteries included. A whole big aspect of the community, of the language, is really community at the end of the day. The people that use the language, us, like the people that come to PyCons, the Python users that answer questions on Stack Overflow, we are a very big aspect of the language. Other than the technical details of the features and libraries, we are a very important aspect of Python. Now, having told you why and how popular Python is, in the rest of this talk, I'm really going to talk about three important aspects of Python, which is some of the challenges the language is facing. I've told you it's popular, but then that doesn't mean we don't have challenges. But also in the face of these challenges, how can we all as a community sustain the language so that Python never dies over time? But also a very important topic, especially that I'm very passionate to talk about today, is how to become a core developer, because I think anyone can be a core developer. I just don't want to be the only African on the core team. So I'm very passionate about this topic, especially when I meet people from the Python Africa community. So let's start with some of the challenges of Python or CPython. So Python is popular, it's been used everywhere, it's evident. That's why we're here, because we find the language as being very useful. There is a Ugandan proverb. I think it also applies to Africa could be an African proverb. It says that even the most beautiful girl in the village has some sort of blemish or in some sort of way. That means they are sort of challenged in some way. And the same analogy can be drawn to Python. Perfect as it is, it solves so many things, but at the same time, it's still facing a couple of challenges that, if not handled, could either break it or it could stop it. And this is what I'm going to talk about today. One of the things I'm talking about. So before what I'm going to be hinting on a couple of words, CPython, Python. So it's important that I define what CPython is. So when I talk about CPython, I'm talking about the reference implementation that Guido started almost 30 years ago and that we are still building on. It's a reference implementation because it basically lays out the specification that any other alternate implementation like PyPy and Jython can aim to be compatible to it. So a great feature of CPython is that it's implemented in C. So in summary, whatever you download from python.org, you're downloading the reference Python in short. And of course, there are other implementations like IronPython that you can always look up to, but we call this a reference because it's a specification, lays out a full specs of how a Python interpreter or runtime should look like. So that's what whenever I talk about CPython, that's what I'm going to be talking about. But also let me give a bit of context in terms of the challenges I'm going to talk about. So my scope is going to be CPython core. I may hint around I may hint around on a few challenges regarding third-party libraries, but I'm going to really focus on CPython core. I will talk about the technical challenges. Python as a language may have other people languages, but that's a talk for another day. And I ask that you do not ask me questions about people languages, especially today. But we can always talk about it alone or individually at some point. Now, if I said I'll talk about every challenge that Python has, I'll be lying. 1 hour is not enough for it. We literally need a whole day to discuss every challenge, nitty-gritty challenge of Python. So without further ado, let's talk. Currently Python is inflated with a lot of open bugs and open pull requests. So on my left, we can see the number of open bugs and bugs closed over time. In some months, it's been fine. In some other months, it's not fine. Like we have more open issues than issues closed at a given time. The general ground shows you that, well, we have so many open issues or very many open issues. However, there's been a lot of effort in trying to make sure that that there's something done about the open bugs and open issues. But I want to say it's not enough. We can do better. So we have around, it's approximated that we have around 30 active core developers. The core developers are many, but we have around 30 active ones. And really, this responsibility of merging PRs and reviewing them is not very realistic for them. That's why we also have very inflated, very open pull requests that are not reviewed. Some are not reviewed, hence that's why they're open, or others are actually left abandoned. So these are all challenges that we're facing. So in short, open bugs and open pull requests, we really have so many of them, and like the people that are able to help on this are still very few. So we would need more help in this area from everyone. So the second challenge is I'll just give it a word: performance. We've all had at different conferences. It could be at your workplace. A couple of people still say Python is slow for some applications. I'm into research, that's why I cite a couple of papers. I have a colleague that's working on solving some of the shortcomings of a Python serializer for Spark. For PySpark, because PySpark and original Spark is not been performing as well as other languages. Now I'm saying we may not get to the like best performance like languages like C, but I think our Python as a runtime is not very different from other languages, and it is possible to have a faster implementation. For example, compared to what we have right now. So this is a challenge, and even in research, I see so many people with research problems around the area of trying to improve Python's performance for it to run faster. So it's one of the challenges and something we should be looking at. Of course, if you want to run a faster version of Python, you should we recommend looking at PyPy. PyPy is an alternate implementation implemented in Python, but it's faster than the reference than CPython, and it has very many. There are a couple of factors that have contributed to this high performance. There is a JIT, but they also have robust garbage collectors. So this is one of the projects you could also try if you're looking for very high performing Python for that matter. So what I'm trying to say is that we should not give up on trying to better at least performance of different aspects of Python, because again, if we ignore this problem, people will move away or will not enjoy the language. So there are opportunities for optimization, trivial and non-trivial alike. And I think this is an area like we all as a community should be looking at solving and giving our view and giving our ideas on the progress in terms of performance of Python. So you can visit speed.python.org to see a couple of benchmarks and how we've been doing in terms of performance for Python over the years. Yeah, so that's it about performance. I hope I've given you. So the other challenge we have is the whole support around C extension modules. So the Python C API has been hailed by many. So we are able to extend Python with C. So the whole idea about C extension modules is we are able to extend Python if you know the C or C programming language. It was intended to be used internally. However, it has so many users, and people have been able to use it over time. Now, the thing is that initially the design of C extension modules wasn't thought. They didn't think about it so much, and we don't blame anyone. We don't even want to blame Github. Projects evolve, and this is just one of the complexities of an evolving project. So the design of the Python C API has posed a lot of maintenance overhead over time, and there is a lot of discussions around how we can best solve this problem. But extension modules have been especially very hard to support for alternate implementations like Jython and PyPy over time. So this is one of the challenges. So I would encourage you to look at this problem if you find the interest. There's been a couple of ideas lying around, others in official PEPs and other ideas in non-official PEPs, probably on a discussion on a mailing list or elsewhere. So if this is a topic you're probably interested in pursuing, you could look around. I'll just give you a few hints. So one of the PEPs by Peter, one of the core developers, PEP 573, tried to solve some of the challenges around this area in relation to sub-interpreters, basically looking around the issue of managing state correctly, especially in the case of us dealing with multiple interpreters at a time. Some other ideas that Victor Stina, again, another code developer, has written in a blog post somewhere. He's written some ideas about what could the design of a new CPI could look like. Again, these are some of his ideas. I just encourage you to go look there, get a hint of what's being discussed so that we can have some of your feedback from after you reviewing some of that. So recently, during the Python Language Summit this year, the PyPy team came up with HPy, basically a solution to go around some of these shortcomings of the extension modules. So they literally came up with a design of a CPI that could easily solve the bottlenecks of especially working with alternate implementation. So I also encourage you to either reach out to the PyPy team or read the transcript of the Python Language Summit to get an idea, but the project is open source, so you can also go find some ideas and give your feedback on the idea, on the project in regards to solving this whole problem of extension modules and how they can be able to be useful, at least to different areas of Python, but also its alternate implementation. So that brings me to my fourth challenge. In regards to performance, a few people have talked about how about we introduce multiple interpreters, for example, and PEP 554, so that we can run processes in parallel. It's a solution to gives us a concurrent exception, a concurrency model, a parallelism model. And some of the challenges that sub-interpreters try to solve is the whole bottleneck around the global interpreter lock. So the global interpreter lock, if you don't know about, it's just a mutex, and it's just a mutex that prevents you from running executing Python bytecodes in different threads all at once. Now, the main idea behind this global interpreter lock was because some of the memory management operations in Python are not thread safe. So the GIL has a very important purpose in Python. However, it has brought also some bottlenecks because now it's not doing well with like multi-threaded programs for that matter. Now, the global interpreter lock is not a bottleneck to everything. There are other operations where it's not a bottleneck. For example, like IO operations. Okay, non-blocking or long-running operations are not affected. Very high number crunching, NumPy operations, for example. So it's not a bottleneck everywhere. However, it's a bottleneck to threaded applications. Now, there is a lot of work required to fully achieve this whole dream of having to support sub-interpreters, and most of the discussions right now is around how can we support the GIL per interpreter. Let's have its scope to have to support a given interpreter. So this is one area that you could also be looking at, maybe helping out in some way. I've done some work around exposing the sub-interpreters. Is not a new thing in Python. It's been there, but we're trying to make it more usable. I think people have been using it, but to be usable, we need to be thinking about more serious problems like that, supporting the GIL, especially for the different. So another thing is garbage collection. Python is based on reference counting, and over time, we've seen most runtimes have moved to using GC, for example. So garbage collection is one area of automatic memory management. It frees us, the developers, of a lot of manual things that are error prone in managing memory. Now, there've been a lot of discussions. Reference counting has a lot of challenges. We've tried to solve some of them. Of course, cycles, we have another GC to work around cycles. However, people have started to discuss around switching from reference counting because of some of the challenges we still can't solve. That are still eminent in reference counting. Most recently, there's been a discussion about moving to GC. It's not a confirmed approach, and several people have had different suggestions of how we could improve the whole idea of garbage collection. Some people are saying, again, because of the bottlenecks of the CPython, we could have a tracing garbage collector for Python and still support reference counting for the CPython, for example. Again, that's an idea, but what I'm trying to say is garbage collection is one of the areas that needs some sort of improvements, and it's of course a long-running project, and so any help on solving it would be highly appreciated. The other area, obvious as it is, and I literally look at this as the most important aspect in CPython, documentation, because that's how we encourage developers to first of all contribute to Python, but also understand the project. It's a very fundamental part of any project, not only Python. So documentations don't receive a lot of love, and I would encourage anyone to look at the docs for Python. A lot of that documentation is missing. Some of it is outdated. Some of it is even incorrect at this point. If you go to the bug tracker, you will notice a couple of issues of incorrect documentation and obvious things like typos. You see, I know that Carol Wheeling is very passionate about this topic from the last time we talked, and I think we'll need your help, and we'll need any help from anyone all over the world to spearhead this, because again, this is a flagship. I feel, at least in my own opinion, this is a very important aspect of any project, and if we don't get this right, we will suffer in the long run in terms of acquisition of users, but also developers in general. So the docs are found at docs.python.org. It's an area you could also. So the other area is workflow. How do we handle the whole cycle of submitting a patch and solving and merging a whole and solving the patch, but also merging a given patch. So Python moved to GitHub several years ago, but not everything moved. So the code base moved. Basically, patches are submitted as pull requests on GitHub. However, the bugs didn't move. Bugs are still on BPO, something we call bugs.python.org. And so there's been 2 PEPs by Marietta to try to transition even our bugs to GitHub. So PEP 5.8 was approved. However, the migration plan, which is PEP 5.8.8, is still underway now. Marietta and the authors of the PEP and other areas about workflow, which could be the projects like that handle the bots. The bots do a lot of automation, and again, Marietta is like a great expert on the bots. Those are projects you could also help maintain and help bring about this whole automation around the workflow of Python. I find that a whole of what the automation really relieves us or contributors of a lot of manual processes, but also moving to GitHub will give us will give the project enough visibility, but also will encourage more participation, because most of the developers in the world are on GitHub. So again, if this is an area you feel you're interested in, you could look around for the workflow projects and give your ideas, because at this point, even the whole migration plan needs your feedback in different ways. So talk to the PEP authors or talk to different people if you have any ideas about the workflow, because it really still needs help from anyone. The other challenge I'll talk about is Python everywhere. We've promised people that we want everyone to be able to use Python on the phone, on a microcontroller, literally on every operating system as well. And on this topic, I encourage you to watch Russell's talk at PyCon 2019. He literally gave a keynote. So we still have so many challenges in terms of supporting different platforms like mobile and web. I've also talked about the whole bottleneck of a C API. It's only supported by CPython. So alternate implementations cannot really be supported, at least automatically, like PyPy. So in short, Python cannot be run everywhere without problems. Yeah, there are many areas that Russell talks about: cross compilation, testing, the support for different platforms is still an area that still needs a lot of help. Something that also Russell talked about was SyncIO for like graphical user interface environments, and like this is something we should be looking at solving if we want Python to be relevant to everybody. So in short, if you want to think about Python everywhere, just join the discussion about how we can support it on different OSs, but also on different gadgets, because if we don't, the language is going to stop being relevant. Because if young kids can't run Python on their phone or a tablet or the different OSs that will keep coming, but also architectures, then we will stop, the language is going to stop being relevant. And that's why I think this is an area that's also a challenge right now, but and needs a lot of help and improvement from everyone. So I have talked about a couple of challenges, and those are just a few of them. We won't have time during PyCon to talk about everything. It will be a lot of whining, and that's not to say that the core team and everyone contributing to Python is not doing work. To be honest, people are sacrificing their time away from their families to do a lot of work. So we should give them a lot of appreciation for the work they do, but also we should acknowledge the fact that some areas are still lacking, and just talk about them so that maybe different people can step up and help in different areas. So talking about challenges is not bad. It's just to start a conversation. Now, what should we do? I started by saying a language, Python, is libraries, what is CPython is and its challenges, the third-party libraries, but also standard, but also a very important aspect is the community, because it's us that bring about the change that we want. At the end of the day, we are the center and we determine what happens in Python. So what should we do? When I think about how to best help Python, I think about two aspects, really. Two people or two groups of people or two units, because I feel if we generalize, then we don't get to practical solutions. I look at individual people like me, users of Python, that are developers or any other kinds of people that use Python. But also I look at collections of people like me, collections under like organizations or companies, and I'm going to talk about these two today. Let me start with organizations. So for organizations that use Python especially, the best thing you can do is support the ecosystem. I cannot emphasize this more. Support the ecosystem, because if Python crumbles, you will also crumble, because you are building on crumbling infrastructure at the end of the day if you do not support the ecosystem. Now, this is not just a recommendation I would give to Python, it's general. Even if you stopped using Python and you moved to Ruby, and I'm not saying Python is a solution to everything. You can move to Ruby, but still, if you don't support that Ruby ecosystem or any other language you'll have moved to, the infrastructure will crumble, and you'll still crumble if you don't support the ecosystem. Now, I'm going to give a few practical ways organizations can be relevant. First, donate to the PSF. The PSF supports many activities around the language. Simple things like donating to even other communities, supporting communities around the world in organizing sprints that provide solutions or advance the language. So that's one area, that's one thing you could do. Again, you can talk to Marlene if you're in Africa. She's a PSF somebody, big person, so she probably knows more about the PSF. But I know that I've also been supported by PSF at some point in my work to CPython. So I think they've been doing a tremendous amount of activities that support the language, and you won't go wrong donating to them. But also allow your engineers to contribute to Python as part of their work time. So most open source contributors take time away from their families to work on open source. But if you can relieve them of some time in the week, like some companies, for example, tell their engineers that we can give you 20% time. You are allowed 20% of your time to contribute to your favorite open source language. In this case, if it's Python, for example. And that is a big relief to developers. They'll really take that time seriously, because you have relieved them of not being able to see their children at different activities because they have to solve something. Yeah, but also the other thing you can do is pay a core developer for just maintenance work. I know a few core developers are actually paid to just maintain Python. We have some, because some aspects, some challenges are really long-running projects, and they need dedicated attention. So if you can pay a developer to just focus on maintenance, that is also good. So that's what organizations can do. Now, individual people like I and the rest of the developers, I'm saying developers, but I'm really talking anyone here. So you can report a bug to the tracker. Don't just stop using Python. Please report a bug. It may appear like there is little progress, but then bugs are actually solved. People actually look at your reports and solve your challenges. This is my professor, my supervisor, my advisor, PhD advisor. He submitted a bug and he was happy that it was responded to in a very short time. So people are really working to solve your problems. Don't give up on the language. We're really happy to know what challenges the language is facing, and we are able to solve. But also, if you have the skills, submit a pull request to solve some of the open bugs. Join the bug triage team to help in like improving the discussion around reporting of bugs, their escalation, and in some sort of way. But also become a core developer to maintain the language and like help other programmers, Python programmers in the world, find the language useful. I think it's a great privilege and honor to be here. So now that will bring me to my last aspect, which is becoming a Python core developer. I'm very passionate about this. I received so many emails from different people on how to become Python core developers, and I'll talk about this today. So first, who is a Python core developer? A Python core developer has the normal responsibilities of contributing to Python. That means submitting patches, reading bug reports, reading bug reports, editing some documentation, reviewing other people's work, triaging issues, but also they have other specific core additional responsibilities in addition to a normal contributor. So first of all, they're very responsible for everything they merge. It's very important. If you merge anything, you have to maintain it. In other words, if whatever you merged introduces problems, it's your responsibility to fix those problems so that the CI is green at the end of the day. Now, this additional responsibility, it's a commitment. It may look simple, but it's really huge, a huge responsibility. And if you're considering to become a code developer, you should think about that. But also you have other responsibilities of being a steward of the language, making decisions about what gets into the language and what really leaves the language. So you can revert merged changes and escalate so many issues about a merged change or even unmerged changes to the relevant mailing list for further discussion. So on top of your contribution responsibilities, you have other more decision-making responsibilities and sort of leadership responsibilities. But also this also comes with the fact that you have to be an example, you have to be respectable in your communication with other people in the community, and don't take that for granted as a leader. Especially, I look at core developers as leaders, yeah, because they make a couple of decisions, so they should be exemplary in some sort of way in their conduct. Now, why you should be a core developer? Some people have so many reasons for being a core developer. I can talk for myself, but I can also identify some reasons why you shouldn't be. Dopamine hits shouldn't be one of them, at least, because I mean, at least you should have another good reason. I mean, it's a valid reason if you want dopamine hits, but at the end of the day, I think being a core developer is a privilege and a great honor to be able to give back to the community of something precious that you use. It's a way of just giving back to the community for the work you're benefiting from. I've been a Python user. Literally every money I have made in industry was because I'm writing Python. So I feel like this is just an honor for me to give back to the community I am part of. But also I want to bring some specific attention to the whole subject of why you should be a core developer, especially in the context of Africa. If you look at this image, this was the core developer sprint last year, and I am just the only African there, and I wasn't even a core developer that time. I was just invited for the core developer sprints while I was in the process, and so I think this also just gives you an idea of why as an African you should be. But let me give you some reasons if you don't have any reason. Why especially we? Dr. Bios talked about how unique our challenges are in Africa. And we are using Python to solve these unique problems. However, we are not represented. So at least that should move you to say, okay, let me try to be a core developer, because if we have a core developer from Africa, we gain more from your representation and your perspective of some of that unique challenges that we claim we have from Africa. Some people say we don't have enough libraries, but in the development of some of those libraries specific to Africa, you may find some challenges that should be handled at the language level. So we're talking about some of these that you should be represented. And personally, I think as an African, becoming a Python code developer gives Python the African perspective, whether you believe it or not. Whatever you will say really will represent us. I am not happy that I'm the only African Python code developer. And first of all, I have been a code developer for less than a year. I will be in a year in September. So Python has been around for 30 years, and just now we're having an African. So I encourage everyone in Africa to please consider trying to be a Python core developer, and let's have, most importantly, to have the African perspective. Not like we just need an African, but to have the African perspective and look at solving some of the unique challenges we we have in the use of Python. At least that's my big note. Now, there are different paths of becoming a Python core developer. I took a different path that may not be your path. So I started through mentorship by one of the core developers called Victor Stina, and I started being frequent in my contribution, and then over time I was promoted. So this may not be your path, especially mentorship sometimes is not realistic. However, Victor Stina and other core developers have tried to mentor. It's not because of bandwidth. Different people don't have time, so much time, so we can't guarantee you have mentorship. However, on DevGuide, we have the process is very transparent, you see, to become a core developer. So start by reading the documentation around being a core developer. So start by asking any questions. There, we have a mailing list that is dedicated to core mentorship. So start by reaching out and become a frequent contributor. The goal is to get to know the project, then review some pull requests by others. At the end of the day, somebody will notice your work. A core developer will notice your work, because at the end of the day, it's about trust. We need to know that you understand the workflow, you understand different aspects of the project. We don't expect you to know the whole of Python. Nobody knows the whole of Python, not even Guido, because the language has evolved so much over the years. So you are not expected to know everything. So, and somebody will open a poll to promote you. So this is it's a very transparent process, and anyone can go through it. I went through it. I'm not the best developer in the world. Some of you are better than me, but you can go through the same process. It's as transparent as this. So specifically, I want to talk about how to get started, because this was my hardest. I tried to contribute to Python 2 years earlier before mentorship, but it was very hard for me. So I've come up with a few steps, and I'm not sure they will really be the end of it all, but I encourage you to clone the source code, try to visit the bug tracker, search the easy issues, and I know from experience that some of these easy issues are not actually easy. So if you're stuck, if you don't still get a very easy issue on the bug tracker, what I usually do is think around my best module in Python. If it's unit test, I open the code, study it, find something that's missing. I guarantee you there is always something missing. Find a typo, a missing test, something is always missing. Alternatively, if you're really stuck, you can write an email to a PEP author and say, where can I help? Do you have a few things that I can help on? That's how I've done it before. There is no one, I don't want to promise it's easy and that if you tried, you are not good. I also struggled to ever be useful on CPython. I've written a blog on the same, and other core developers have also written blogs on the same. So you can read around and see how you can get started to contributing to CPython. So as I close, Python the language is a community and its libraries. If we do not support it, the developers and organizations alike, we are going to be building on crumbling infrastructure, evidently, over time. The language is popular, very useful, and very useful and will continue being useful, but it still has challenges that we need to be thinking about as collectively. So I'd love to end with a few quotes. Remember, projects stop being relevant when problems are ignored. So if we Python is no exception. It's like any other project. So if we ignore the challenges it's facing, over time, it's stop going to be relevant and people will stop using it. So let's try to think around these challenges. Borrowing also from Abraham Lincoln, I would love to say, I just literally paraphrased or made his quote relevant to us. Ask not what a programming language should do for you. instead ask what you can do to bring about what you want. So the good thing is Python is open source, so you are very free to suggest any new ideas you have and suggest anything we should fix to make sure you're running seamlessly. So instead of blaming or saying, oh, Python is so bad, try to think around what you can do to bring about the change you want. So Guido open source Python for this idea, for the fact that let's all come together and reason together about Python. And that's how we are going to advance the language. So that's it about my talk today. And usually I ask everyone at the very end, who will bring balance to the source. The source is Python, and I always ask for the force to be with everyone. And we'll see you in the source code as we battle some of the challenges right now. So I will invite any questions. Thank you.
Hi, everyone. So I'm just going to be helping Joe out for a bit with Christian and with answering some questions. If you have questions, please post them in the comments. We're just going to take a few minutes because we are running a little bit behind. But I know that a couple of people asked questions. Mamadou was saying, how about types for performance and big development?
Sorry, I didn't
get that.
Sorry?
Yeah. He said, how about types for performance and big development? I'm not sure exactly what he was.
I mean, types as in static typing? I mean, in that regard, maybe. Well, if it's in the regard of types, I've seen by types, I think you mean static typing. There is a lot of research around types and their support for dynamic languages and how they could improve performance. I know that Guido and other people are working on MyPy, which is some sort of static checking for Python. You can follow up on that project as well. And other research is coming up around using types in dynamic languages that you can look up. So I greatly think that's an area we could pursue and improve the language in.
That's so great. Yeah, and he confirmed that was what he was asking about. So great. And then Jeff was saying, does the sub-interpreters, will they be faster as async? I'm not sure if he's meaning that, will it make it faster than async, or I'm not really sure what he means by that question.
Yeah, so I think, okay. What I can say about sub-interpreters is definitely if we are running a couple of different processes in parallel in different interpreters, we will come to better performance. Now, if you can read about PEP 554 on its relationship to async IO and how it complements async IO in that regard. However, we expect better performance because if we're running different things parallel in different interpreters, we expect a better boost in performance.
Right, definitely a good thing. Does anyone else have any other questions about that? Yeah, I think the sub-interpreters is super interesting. I know I've read a lot about, I've watched a couple of talks about.
So actually, we can talk about this after the talk. I'm also very interested in the PEP. I've implemented part of it. At least it lives in the test suite, so we can talk more about it. But also read PEP 554, for more detail.
Awesome. Then Daniela has a question as well. He says, thanks so much. It would be wonderful to hear. Sorry, I'm echoing a bit. Thanks so much. It would be wonderful to hear your perspective, Joannah. It's been wonderful to hear your perspective, Joannah. It seems that so many people who get into a position like yours have learned how to do it all over again each time, as if they were the very first. If I have a chance to ask a question, it would be, do you think it would be possible to create a guidebook or a pathway or something like that that African Pythonistas would be able to follow? So that, yeah, I think that's a great question. Do you think there would be?
Yeah, that's an interesting question. I'm just not understanding the context. To follow to become a core developer, if it's in that regard, it would be an idea I would be happy to collaborate on. It could be as simple as a GitHub wiki page. It could evolve into something else if you find it useful, a book or something. But I would be highly interested in collaborating on something like that, because the whole aspect of being a core developer thinks like it's for some different people, and I didn't know I would ever become one. So yeah, we can talk about it. There are different ways. I can only give some of my opinion, but also other people would be happy to collaborate on, including the core team. I'm sure they probably would love to put in their efforts, but also I can give my perspective on some contextualized African way, per se. Yeah.
Oh, that would be great. I mean, I think that's a great idea, and I think we should, yeah, we should take that up as a community. I would love to see that happening. And like you said in your talk, I would love to see more African Python core devs. I mean, it would be so great. So yes, Daniela, I think that's something we should talk about and try and make happen. So I'm not sure. I think those are all the questions that we have. We are running a bit behind schedule, but I don't know if anyone has a last question before we close the talk. Someone is saying, so Mamadou is saying, is it a must to be a C expert to be a core dev given the C API?
So a lot of Python is written in C, but a lot of it is written in Python itself. So you don't have to be a C developer to contribute to Python. A lot of code is in Python. So everyone is welcome. If you know Python, come. There is something for you to work on. There is also the C parts to work on as well. Yeah.
Yeah, that's good to hear. I think it can be intimidating, the C part of it, you know, can be very intimidating. But I think that's all the questions we have time for. Thank you so much, Joannah. We really appreciate you. We celebrate you as part of our community and being a core developer. So yeah, thanks everyone. Thanks, Jo.
Yeah, thanks everyone.